Okay, hey everybody. Well, this is coming up. I just want to talk about what we're going to do today. So we've got section 5 for day 1. Oh, it's already up. Okay, whatever. Section 5 for day uno, day 1. Okay, we're going to spend a couple days on section 5-4 just to let you know where we're headed. Okay, just to know that let you know where we're headed. Obviously, today is Friday. Tomorrow is sorry, I was just getting a text message. Today is Friday. Monday, we are going to continue with section 5-4. Tuesday, we're going to do section 5-5. Wednesday, what we're going to do is we're going to go over the homework from section 5-5. And then what we're going to do a little ACT crash course stuff. Mrs. Peterson's made us a really good video on how to find some resources that I'm going to post on Canvas, and we're going to watch it together as a class. But it's some good stuff. Some good stuff. Okay, so what is section 5-4? Section 5-4 is this. Completing the square. Get it? See what I did there? I'm so funny. Okay. All right. So go ahead, guys. Section 5-4 is kind of difficult, but you guys are fine. You guys are honors kids. You can do it. Okay. So section 5-4, completing the square. Okay. Thinking back to sections 5-1 to 5-3. And again, I'm sorry, I'm sick, so excuse me while I get drinks and blow my nose. I'm really, I deeply apologize. All right. So, thinking back to our first section 5-1 to 5-3, how did we solve quadratic equations? Well, we had to factor them. If we were not able to factor them, we could not do it. Okay. So what I'm going to teach you today is a method that will work every single time. It's called completing the square. Completing the square will work for every single quadratic because we know that only certain quadratics can be factored, but every quadratic can use completing the square. Okay, so many quadratic equations contain expressions that cannot easily be factored. For equations containing these types of expressions, you must use what's called completing the square. All right. So take, for example, this. Like, how would I factor that? Well, this is not a perfect square, and this is not, well, I'm sorry, this is a perfect square, but this is not, right? It cannot factor into anything like that. So what can I use, right? Well, sometimes you can just solve straight up for x if you don't have a b term, like this guy. I add 12 over to the other side. When I say it doesn't have a b term, look, it's like a 0x in the middle there, right? There's no x, there's no just b term. Okay, I add 12 over to the other side, I get x squared is equal to 12. And then when I square root it, now here's the deal. Like, take, for example, this equation. Or, as a side note, take, for example, this equation. What numbers can I plug in for x? Well, obviously positive 3. But can't I plug in negative 3 as well? Isn't negative 3 also a solution to this equation? So we have to consider both roots, both the positive and the negative. So when I go to square root 12, I have to consider both the positive and the negative root of 12. Okay? Now, no decimals in this section. We have to use only simplest radical form. What's that mean? Break this guy down. We did this in the beginning of the year. Remember, this is the only time I'll show this. Like, this is the buddy system thing. 2 and 6, 2 and 3, buddies, 2 radical 3. Okay? Every time, it's got to be in simplest radical form. All right, so this is what's called the square root property. Write down if you need to, but it's really kind of simple. If you have no b term, get the constant over to the other side and square root it. Just make sure you simplify the square root. Like this guy, that can't be simplified. Plus or minus. Don't forget about the plus or minus. Okay, pause where you need to and write stuff down. Oh, yeah, plus or minus. I'm saying it, so yeah, I guess you know what it is. All right. Again, I have said this and I will say it again. No decimals, please. The only time you're allowed to do decimals, word problems. Do you notice as there's no b term here? There's no x term. So what do we do with it? Subtract 11. We get 4x squared is equal to 48. We divide by 4. x squared is 12. And look, there you go. X equals plus or minus 2 radical 3. We just did that problem. There's my answer. Take a look at this one. Okay, so there's no real b term, but I do have something. I have a quantity squared over on the left side. Well, how do you undo a square? We take the square root of the opposite side. So this is like saying x minus 5 is equal to plus or minus. Don't forget, whenever we take the square root, we take a plus or minus 3. Okay, well, this notation is a little weird, but what I really can do is just create my two separate equations now. Like just like I did when I was factoring, like whenever I get down to something that's like factored form, I set this equal to 0, I set this equal to 0. I could create like two little equations, set each one of them equal to 0. Same type of thing, but I'm not setting them equal to 0. I'm setting them equal to plus or minus 3. X minus 5 is equal to positive 3. X minus 5 is equal to negative 3. Add the 5. Add the 5. Those are my two solutions. Don't believe me? Plug it back in if you want to. Trust me. Okay. So we're noticing here that if we have a quantity squared, we can do this whole square root property thing. But wait a second, Mr. Laverick, you said there would be no b term. Ah, I see a b term. So what do? Anybody see it? Can that guy be factored? Oh, it can. Factors of 36 that I had to get to 12? 6 times 6. So this is like an x plus 6. X plus 6 is equal to 28. Is there another way to rewrite that? Oh. Isn't that meaning the same thing? Oh, so this reverts back to what we did up here. Oops, that doesn't scroll. Right? We had a quantity squared is equal to 9. A quantity squared is equal to 28. So x plus 6 is equal to plus or minus the square root of 28. Let's see if 28 factors down. Let's buddy up. 2 and 14, 2 and 7. Okay, 4 radical 2. Or, sorry, excuse me, 2 radical 2. X plus 6 is equal to plus or minus 2 radical, what am I saying? 2 radical 7, excuse me. Now, whenever you have a radical term over here, I would want to subtract the 6 over to the other side. And I take negative 6 plus or minus 2 radical 7. And that's my answer. Why am I not separating it into 2? Because can I actually take negative 6 plus 2 radical 7? Like if I wanted to, like you could go into your calculator, but guess what? It would spit out a decimal to you. Okay, nothing else. Okay. All right. The methods in the previous examples can be used only for expressions that are perfect squares. However, completing the square is forcing, it's kind of like square peg, round hole. I am forcing the square peg into the round hole. I am forcing every single quadratic to become a perfect square. You can do that. I promise you, you can do that. Okay? And that's what's called completing the square. X squared plus bx cannot model perfect square. But what we can do is we can put something on the right side and add it to that to force it into being a perfect square. It's called a perfect square trinomial. It's got even a fancy name. Okay? Go ahead and write this box down. I would write this box and the algebra box down. We'll do examples. I'll give you a minute. Okay. To complete the square, what we actually do is we take b divided by 2 and we square it. And what do we do with it? We add it. Okay? So like think about it this way. X squared plus bx. I'm going to add b over 2 squared right here. Okay? So for example, x squared plus 6. X, excuse me. Take half of b, 3, square it, I get 9. Now, I'm going to write a 3 right there because that's 6 over 2. Right? Now, what does that mean? Watch what happens. This guy goes right into there. Okay, that always happens. Okay, this b over 2 thing always goes right there. Always and every time. So let's see how this works. Let's practice it a little bit. Again, this is just we're crawling before we walk. What fills in this blank? Think for yourself, what would fill in that blank? Would a smiley face fill in the blank? Would a stick figure, a person fill in that blank? No, 49 would fill in that blank. What's half of b? -7. What's -7 squared? 49. So that fills in the blank. Now think about it. What factors of 49 that add to get to -14? Oh, that's -7 times -7, right? Oh, shoot. So it's x minus 7 squared. Okay. That number always goes there. Always. Oof. Oof. What's 9 over 2? Don't say 4.5. No decimals. Ooh, that means we got to work with fractions. Are you kidding me? Are you kidding me right now? Fractions? We're not talking about whole numbers. We're not talking about whole numbers. We're talking about fractions. We're talking about fractions. Oh, no. All right. So what's half of b? 9 over 2, because that's half of 9. Okay. What's 9 over 2 squared? 81. Oops, I don't know what that guy is. 81 fourths. Okay, so 81 fourths fills in that blank. So you may be asking yourself, okay, well, how would I factor that? What are the factors of 81 fourths that add to get to 9? I don't care. You want to know why? Because it will factor into x plus 9 halves squared. Yeah? Where this one, it was really easy to see that, oh, 49 was saying -7, -7. You don't need to do that. You don't need to do that extra work. It's just b over 2. Okay? Try this one on your own. All right. B is 3 over 2 is 3 over 2. Squared is 9 over 4. X plus 3 over 2 squared. Okay, now how does this help us? You may be thinking, this is ridiculous. Why are we doing this? Right? That seems simple. Take a look here. I want you to write this whole thing down. This will make a little bit more sense on Monday when we have to do some other steps along with this. Today, what we're only going to do is take this piece, okay? I'm going to add steps 1 and 2 back on Monday. So I would for yourselves right now, pause, write down this entire list. Don't just write down 3 through 6. Write down the entire list, okay? I'm going to go through this again on Monday, and it's going to be a little bit clearer, I think. Should be, okay? All right. So let's complete the square. Let's do it. All right. First thing, get all variable terms to the left side. Variables to the left. Constants to the right. All right. Now, I leave some room. Ooh, I mysteriously left room. I'm going to complete the square with this piece in here. Okay, so what fills in my blank? Well, what's half of -12? -6, right? What's -6 squared? 36. I'm going to complete that square. Okay, well, if I add 36 to the left side, I've got to add 36 to the right side. Oh, shoot. That means that this is x minus 6 squared, because again, what was -12 divided by 2? -6. And this is 16. Holy chicken nuggets. That means this is x minus 6 is equal to plus or minus 4, because I square root, obviously. And that means I've got x is equal to 6 plus or minus 4. Well, what is that? That's x is equal to 10, 6 plus 4. And x is equal to 6 minus 4, 2. That's completing the square, folks. That's fancy. That's nice. This way's going to work every time. Okay, first step, variables to the left, constants to the right. Here we are. I add both parts to either side. Okay, well, what am I going to add to either side? Well, what's half of -4? -2 squared, +4. Add 4 to the left side, I got to add 4 to the right side. So this is going to become, well, what was -4? Oh, divided by 2. -2 I could say, okay, what are the factors? Negative 4, but I don't need to do that. It's always b over 2. Okay, 31. Now, here's the thing. Look here. This guy does not, or girl, excuse me. Thank you, Clef. This guy, whoa, that was a big cough. This one doesn't factor, or excuse me, this one doesn't square root. Does 31 reduce? Nope, it's prime. Okay, so that means I just add the 2 over to the other side. Add 2 plus or minus the radical 31. You may be thinking to yourself, well, why'd you put it in front? Couldn't I have written this plus or minus the square root of 31 plus 2? Yes, but I know you guys, and you guys get sloppy, and you would have written it like this. Plus or minus the square root of 31 plus 2, right? And then it's like, okay, is the plus 2 underneath, or is it not? No confusion here. Okay, do it my way. Try this problem on your own and see what you get. This one's a doozy. If you need to, if you cry uncle in the middle, that's okay. Okay, let's try it. X squared minus 9x is equal to 2. Can I have to work with some fractions? What am I going to add to both sides? Well, what's negative 9 divided by 2? Negative 9 over 2. Okay, so that's, what am I adding to both sides? That means I'm going to add 81/4 to both sides, just like we did earlier. Okay, so that means that this is going to turn into x minus 9 halves squared, right? We don't have to do any additional math. We know that that's going to just transfer. No, but what is what? 2 plus 81/4. Now watch. Let's get fancy here. What is 2 in terms of fourths? Right? What is 2 in terms of fourths? Isn't that just 8/4? That means this is 89/4. Square root the opposite side. X minus 9 halves is equal to plus or minus the square root of 89 divided by the square root of 4. X minus 9 halves is equal to plus or minus the square root of 89 all over 2. That's a 9. X is equal to 9 over 2. Add the 9 halves over to the other side. Plus or minus the square root of 89 all over 2. That is an acceptable answer. What is also acceptable? 9 plus or minus the square root of 89 all divided by 2. I told you it was a doozy, folks. I tried to warn you. Okay. Try your homework. Do the best you can on it. Homework is page 345, numbers 2 to 9, and 20 to 27. Whoa, that is some awesome handwriting right there. There you go. Have a great day, everybody.